Hey everybody, we're going to get started here, so try and grab a seat and get settled in. This is WEB301, Operational Web Log Analysis. Hopefully this is the session that you were looking for. With that, I've got a lot of content to get through, and unfortunately only 45 minutes to get through it. So with that, I'd like to get started. My name is Chris Munns. I'm a solutions architect for Amazon Web Services based out of our New York City office. I've been with AWS for a little over 3 years at this point in time. Real quick, just want to note to say that unfortunately I'm not going to be able to stick around for questions after the session. I actually have another talk directly after this at 2:15, deployment automation in room 3001. So if you like me enough, follow me on over there, and maybe you can ask me questions about this session after that one. Otherwise, you can hit me up at Twitter at Chris Munns, or email me, munns@amazon.com, for any questions that you might have. So I always like to get a good idea of who's in the room here. Who here feels like they do a good job of processing, understanding, collecting, aggregating their log data today? Okay, so good hands, that's good. Who thinks that they could improve upon it? Awesome. Well, hopefully you'll get some ideas here today, or to both either start doing this process or improve upon the process that you have already today. I like to start my talk sometimes with a quote. This one is on the importance of logs, and essentially what it says is that log data contains some of the most valuable raw information you can gather and analyze about your infrastructures and applications. This was clearly said by a very, very wise person. Actually, it was said by me in a blog post back in May on our startup blog. And so I wrote this post for our startup blog when we first launched it, and was actually very, very surprised by the feedback. I got reached out to by a whole ton of customers of all different sizes. Even though it was on our startup blog, I got reached out to by enterprises. And they said, we need help with this. We're not doing it well. How can we do it better? And so it kind of influenced me with the idea of doing this talk here at reInvent. And so essentially that's hopefully why we're all here in this room today. So what is it that makes logs important, right? Essentially, there's just a ton of information that you can garner from the logs that exist inside of your infrastructure generated by your applications of all sorts and shapes and sizes. Things such as, how is your website or your application or whatever process it might be inside of your large infrastructure performing? Are there errors in your code? Are people potentially attacking your site, right? Security-based information that you could find in logs. Are those attacks successful? Are they not successful? What type of content are people, accessing frequently? And, other information, even things such as, where are my customers coming from? Unfortunately, though, working with logs can be very, very hard. There's a lot of different things about working with logs that make it difficult. Starting out with the fact that there could be numerous sources, right? Throughout your infrastructure, you might have various different resources that are capable of generating many, many, many logs. And again, even on an individual instance, for instance, if you start up an Amazon Linux instance today, you're going to find a little over a dozen log files that are generating log entries just by the instance running. So OS-based logs, application-level logs, web server logs, all sorts of different things that might exist there. This is also very, very high-velocity data typically. If you think of a typical request to a website that maybe has some CSS, some images, some JavaScript, other content embedded upon it, that single page load could be generating 10 plus times the amount of log entries for that single request, again, based on all these other assets that you might have there on that page. When you take into account that you might have multiple tiers inside of a single application flow, for instance, typical 3-tier application where you've got a web server talking to an application server, talking to a database server, you could be generating logs across each of those various places as part of that one single request. So it can be very, very high data velocity, much higher than your actual traffic or user request base. You also run into varied log patterns, and we'll talk about this a little bit later here in this talk. And then lastly, it's very much like searching for toothpicks in a pile of toothpicks, right? When you look at log files in the raw, it's nearly impossible to be able to pick out the things that are important to you. Again, talking a little bit about where logs can come from. If we look at this diagram here today, we have an application, maybe it's being accessed by a native mobile client, maybe there's a browser-based aspect to it, serving our content from a CDN. That CDN then is reaching back to origin, maybe for static assets from S3, reaching back to our actual web server through ELB, to our web tier, through another ELB, to an app tier, to a database. And if you were to think of which components it is in this infrastructure that could be generating log files for you today, the fact of it is all of these things. Nowadays, many native applications that people are writing for iOS and Android, they're actually doing log collection on performance and access patterns, shipping that back to them. And you also see people doing a lot of real user management and metric collection from actual user actions on web pages as well. And once again, when you're looking at this pile of toothpicks, you have to figure out which one of these matters the most to you, or which one of these is going to be insightful. All right, looking at this, how do we know that this one is important versus this one over here? And the reality of it is, unfortunately, we're not looking at toothpicks. We're looking at wonderful walls of text like this that go scrolling by. If you've ever tailed a log file in a very active system, and the same question applies. Do we care about this one, or do we care about this one? So a lot of things here, again, that make working with logs very, very hard, and a potentially complicated process inside of your day-to-day operational workflows. So I like to kind of step back and kind of bring us forward into how we got into where we are today with logs. So let's go back to the beginning here a little bit and work ourselves forward. Essentially, syslog is really kind of the modern interpretation of log analysis or log collection that we see today. It actually dates itself back quite some time now, over 30 years, to a gentleman by the name of Eric Allman, who was working at UC Berkeley on the SendMail project. And when he was working on SendMail, he was looking for a common structured way that he could collect logs from SendMail, and came up with syslog, which at that time was just a pattern for log files and not a daemon or more of a process that you would see today. And so he came up with a standard, and it was actually very well received by the Unix community. And so it became kind of a loose standard inside of Unix and kind of spread like wildfire from there to the point where you see syslog integrated into hardware devices today from various network providers and other pieces of hardware that exist. And then eventually in 2001, almost 20 years later, it actually got standardized into an RFC, RFC 3164, which became the BSD syslog protocol. One of the key things that syslog defined was this concept of a facility and a severity. And essentially, you could think of a facility as the process or the thing that was creating this message, and then a severity, pretty straightforward. How important was this message to me? What type of content might it be covering? And then eventually, later in 2009, this RFC was superseded by RFC 5425, which is the more common one that is known and used today. If we go back and look at what RFC 5425 defines as a syslog message, we see what is this line entry right here. And this is actually the example that they have from the documentation. And if we want to break this down and understand what it is in that nice little complicated line of text, what we see at top is that there is the facility, which has a number representation, numerical representation, multiplied by 8, added with the severity. We have a version of syslog potentially. There's a timestamp, which has its own RFC. There's a host name, an app name, a proc ID if this was a process that was running, structured data that could be passed in, a message ID, message encoding, and a message. So a lot of different things in this one log line that tell us about what's going on in our application or in our infrastructure or on an instance for us. So this sounds pretty easy, right? It has a common structure, it's well defined, we've got facility, we've got severity, the Unix world likes it, everything should be great and wonderful. Unfortunately, it wasn't great and wonderful for everybody, and so what you started to get was differing syslog protocols that started to exist. So in 1992, the National Center for Supercomputing Applications released their version of HTTPD, which was based on the original one that Tim Berners-Lee had wrote. And then eventually in 1995, this became Apache, which we all know today. And Apache, and actually technically the NCSA HTTPD, had its own log format, which became known as common log format. So common log format is something that we're probably much, much more familiar with today. You'll see this on Windows servers, on Linux servers, across application types. If you get CDN logs, they look very similar to this. Load balancer logs. Anything that's processing HTTP these days pretty much follows this type of log pattern format. So again, a little bit more readable here. And if we want to break this down and do the comparison of, again, what these different fields mean, what we see up first is we have an IP address. We have a user identifier for the old ident-d protocol, which is actually largely dead, but by default, this is still something that gets logged. We have a user ID if this was going to be an HTTPD or CGI-based application for authentication. Again, nowadays, most people are not using that for authentication. They're using something inside of their application to do that, so another kind of dead field. We have a timestamp, again, one that has its own RFC. We have our actual request, in this case, getting the root document of this web server. We have an HTTP status code, a size and response in bytes, in this case, size of the response, I'm sorry. We have a refer if there was one, and then we have the user agent. So pretty straightforward, a lot easier to read, a lot easier to understand. Some dead information in here, but this at least gets us forward into where we are today with logs. So again, a little bit of a history lesson, but now let's move forward and actually take this and make something useful out of it. So what we're going to talk to you today is my 4-ish steps to operational log analysis with an asterisk being there, that these 4 steps are actually several mini steps, but I like saying 4 instead of saying like 29 or something like that. I think it makes it seem a little simpler. So let's go into these now. So the first one is to generate useful log data. Pretty straightforward here, right? If we're going to be trying to do something with this data, we want the data that we're generating to be as useful as possible. There was an earlier talk today at 11 o'clock on web server optimization, where a peer of mine and Justin Lynn from Chartbeat talked about how generating logs on your web server is actually an impactful thing, right? You're eating up potentially disk cycles, you're using up some CPU. So if you're going to be doing that, you want those log files to be worth exactly the resources that you're consuming with them. So if we go back and look at my example Apache log line that I have here, in this case, this is from pingdom hitting my web server to make sure that it's up and alive. What we can see in the bottom box here is how Apache represents this log file inside of its configuration file. So Apache does this wonderful % letter symbol thing here to help us define what these fields represent. And essentially what we can do is we can play with this and configure it and make it more worthwhile to us. If you go and dig into the Apache docs, you'll see that there are a couple dozen actually different parameters that you could generate inside of a potential log entry. For instance here, %d is the time taken to reserve the request in microseconds. %t is the time taken to serve the request in seconds. Hopefully we're not dealing with second-based web page generation, but still does happen. And then towards the bottom here, the more interesting ones, %, and then in brackets, some variable, in this case foobar c, and below that, foobar n. For C, in this case, you can actually pass in cookie information to your log files. And then N is from a functionality of Apache called Apache Note, which languages like PHP and others can actually toss data into a log file from inside of your applications. So lots of different customizable capabilities that we have here in generating these log files. So if you go back to my example here, again, I have this pattern up top initially. This is the default that comes inside of Apache. And we can see how I have these 2 kind of useless hash marks for me next to the IP address in the second box. And there's other data that I'd like to add. So in this case, what I'm going to do is remove those 2 hash marks, the %L symbol and the %U, and replace those with %V, which is going to show the host that is actually handling this request for me. And then I'm going to add in later on %D, which is going to show me the time that it took in microseconds to serve this request. Again, you can think that that would be a lot more useful information for me, gathering that bit of information and then using it later in my log analysis. And again, there's just a ton of things that you could add into a log file like this. And then the result is kind of the bottom box here, where you can see that this request was served from php-app1, and then we can see the time in microseconds that it took for this web page to be served. And not to sidetrack and ignore Nginx in this, again, something that many, many people in this room are probably using. It has very similar capabilities of altering your log files. Wonderfully enough, in Nginx, it's actually a lot cleaner to understand the syntax of what these log files look like. You can see an example here, $remote_address is a lot easier to understand than %h. So we've gone and made our log data useful, right? We've cleaned out things that we don't need. We've added in some fields that we do need. That's important to us. The next thing that we need to do is actually do something with this data after it's been generated. And so the first thing that we want to do is get this data off of our web instance if possible. So I see there being kind of 2 different patterns and ways that this could be done. The first is to centralize the log data in its raw format first and then do analysis on that centralized data. The second is to do analysis on the host and centralize the results. So 2 different patterns here. At the end, though, still kind of a common result that we're going to get out of it. And essentially, either way, you want to make sure that you're getting your log data off of your host as quickly as possible. And many people would say, why did that? Why does that matter? Why can't I sync it up once a night? Why can't I sync it up every hour? And the reason is, essentially, that instance failure happens, right? Hardware can die, instances can kernel panic, all sorts of things can happen. You could potentially fill your disks, depending on if you had a large burst of traffic and you weren't prepared for it. And then lastly, if you use auto-scaling and you have instances being brought up and down, if those instances are allowed to scale down and be terminated on you, if you aren't doing something to get those logs off ahead of time, you're potentially taking data and throwing it away. So again, I really encourage the idea of taking this log data and as close to synchronously as possible, getting it off of the host as soon as the data has been generated. So if we go with the option of centralizing the data first and then we'll analyze it later, there's a number of different options that we have here. And we're going to kind of go through a bunch of these here now. So the first is kind of the most straightforward, what I kind of consider the lowest level here, the open source options for log centralization, syslog-ng, rsyslog, and nxlog. These are all kind of based on the original concept around syslog and syslog-d, which was kind of the first daemon used for centralizing log data in Unix operating systems. Syslog-ng and rsyslog are usually primarily Linux-based. nxlog is a popular Windows Server log centralizing tool. And again, they're all variants off of syslog, but advanced in terms that they now offer things like TCP as a delivery mechanism, security, filtering, and other good things there. Typically, these will run as an OS process and tail and capture your log data and then ship it off to some centralized place. We can see here in the kind of the diagram of how this works. I'd be running one of these daemons on top of one of my instances, and then they would be pushing it to some sort of a centralized place. And the other great thing is that usually these daemons can take logs from third-party places in the centralized aspect, that is. So you could take your hardware syslog capabilities and point it at a centralized syslog-ng or rsyslog server and collect that data from your network devices. So these are the pros of the open source options that you have here, but there are some cons, right? So this is only part of the problem for us. This is going to get that log data moved into a central place, which is useful. But then after that, we still need things like analytics, dashboarding, and so we're going to be needing to add at least other tools on top of this here. Typically, this centralized component that we have here, which again is a very common pattern, at scale can become a bit of a bottleneck. Right? You have to worry about scaling that one server. You have to worry about overwhelming it. And I've actually seen in very high traffic situations where spikes of traffic can cause a syslog server to become overwhelmed, and that overwhelming of that syslog server could have ripple effects upon other parts of the infrastructure. And again, the scaling aspect of this becomes a problem. At some point, you have to think about federating out among multiple different centralized syslog servers. And so it's not really a simple, clear path to doing this at very, very, very large scale. The next option is kind of the complete opposite of this, is to go with an enterprise tool, potentially something similar to Splunk. So we saw Splunk on stage today in Werner's keynote. Very awesome product, right? Enterprise grade, lots of huge enterprise customers using it across federal government customers, healthcare, startups, everything in between. Extremely scalable product. I've personally used Splunk in a multiple hundreds of gigabytes of log data being generated in a single day at a previous job. And so we use Splunk very heavily, and it just was rock solid in terms of being able to aggregate, store, and then present out my data to me. Splunk offers up built-in fault tolerance. There's security of the data that you can have layered on top of it. It can technically also accept data from third parties, so you can push syslog data into Splunk, which is pretty cool. And then the thing about Splunk is that it really is that full package, right? So it's going to give you log forwarding, it's going to give you analyzing capabilities, dashboarding capabilities, and third-party apps that you can plug into it. We can see here in the example of the network, what I'd be running in this case is either a light Splunk forwarder or the Splunk agent on the rest of my infrastructure, and then pushing that data into my indexers. They support the ability of you being able to essentially round robin across the indexers, which is a great way to scale and handle, again, bursts in traffic and high availability and redundancy. So again, pros here on Splunk and enterprise-grade services like it. Some cons. Unfortunately, with enterprise quality applications comes enterprise pricing and licensing, right? Not the freest of services and pieces of software that are out there, but again, very much worthwhile to the money that you'd spend on it. And then in terms of scaling potential bottlenecks, the indexers can become that bottleneck. Typically with Splunk, you license based on the amount that you're going to index in a given time period, split up across the number of indexers that you have. And so these indexers become a little bit of a rigid aspect in this case. And I think that's kind of why Splunk has this really great SaaS offering now, and it helps you kind of get around any of the hard resource requirement bottlenecks that you might run into. So we've covered kind of the very low-level open source, we've covered enterprise, and then now I'd like to cover another option, which is a little bit more in the middle here, another open source option, which is called Logstash. This is part of what is known as the ELK stack these days. We'll talk a little bit about that further on. This is another open source tool. It's extremely scalable. It has fault tolerance built in. It's actually supported by the company that makes Elasticsearch, called Elasticsearch. Very, very active these days. I have been following Logstash for the better part of the last 2 years and have been seeing it pop up all over the place. Massive enterprises, startups, again, kind of everything in between. A very active code base, a lot of people committing code to it, and so that's kind of contributed to its popularity. It's very pluggable. If you go to the website, you will find a ton of different options for plugging into it and working with it. And then lastly, it does tie directly into dashboarding and analytics tools, which is the completeness of what's known as the elk stack. And again, we'll be talking about that a little bit later. The diagram here you can see is a bit more complicated, right? I've got my web and application servers at the top. There are a couple of different logstash forwarding agents that can run. They have a light forwarder, and then they also have the regular logstash application that you can use. The lighter one is Lumberjack. And there's a couple others out there that are kind of part of that ecosystem. So I'd be running that on my actual application and web instances. And then typically what you would do for scalability reasons is send those logs into some sort of a queue or a buffer space. Many people choose to use Redis for this. And so here you can see, maybe I'm using Elasticache Redis to handle this so I don't have to manage it myself. And then you need something to pull those logs out of that Redis queue or buffer, if you will. So you use the actual logstash daemon, which then puts the logs into Elasticsearch as its backend index. And this is where you would send the logs for longer-term storage and eventual analysis. So a little bit more complicated than the other options so far. And that kind of is really the biggest con today I see with Logstash as part of the overall elk stack, is just kind of this complexity of the very different components that you have to manage and run yourself. So there's definitely a lot of do-it-yourself that you would need to do in order to get the full elk stack up and running for you. A lot of it's based on Java. You're going to spend some time becoming familiar with the JVM at some point if you get to a very large scale, which if you're not familiar with, can take some time and tuning. And then the last bullet point here that I have listed as a con, many people would see this as a pro, and I find it kind of straddles the fence. When you have open source projects like this that are very rapidly moving, very rapidly changing, sometimes what that can mean is you can be kind of left in the dust very quickly in terms of new capabilities, new functionalities, incompatibilities between versions and stuff like that. But that said, it's still a really, really great tool, and I think probably the most popular open source option that I see out there today. And then lastly, we have hosted options. So hosted options, pretty self-explanatory. You're going with a third party to host the log collection, storage, analyzing of your data. Great things about hosted, right? Very easy to get started with. You don't need to do anything usually on your own to get this going. These will work usually either via an agent or via some sort of syslog daemon, sending log data to the hosted SaaS offering that you're working with. You don't have to deal with scaling yourself, which is great. They typically usually have very flexible pricing models. They have support options, and built-in dashboarding is usually part of all of these. And then lastly, which I think is probably the most important part of any SaaS offering or cloud in general, is that they obviously have this company behind these products that are continually building and adding features and watching these things grow in complexity and capability for you. So a couple of, all of the logos that you see here on the bottom left are partners of ours. Many of them are here this week at the expo. So I definitely encourage you to go and take a look at them. For those not familiar with the little beaver guy down there, that's Loggly's mascot. And so again, lots of pros here to SaaS models and lightening any sort of operational burden from you yourself. In terms of cons, right, pretty straightforward, understanding what SaaS models mean for you versus doing it yourself. If you're super concerned about your data, right, you want to work with these companies and understand how they're securing and storing your data for you. What kind of controls are in place to protect your data in their environments. And then obviously you're slightly restricted by what these various SaaS-based options might be able to do. Right? There's going to be restrictiveness in terms of how the agents work, how you're getting the logs to them, and then potentially how you're actually analyzing the data, viewing the data, and so forth. So again, depending on what kind of level of flexibility you're looking for and complexity, you kind of have to make that decision. That said, I'm a huge proponent of SaaS model type things. I feel that if you are a very small team that maybe doesn't have a ton of extra operations time or extra development time, right? Why spend the time to figure out how to do something like the elk stack or one of these other solutions, right? Just take it and outsource it and worry about bringing it back inside someday when you have more time, more money, whatever it might be. So that's the conceptual idea of centralizing the log data first. How about analyzing the data first? So in this case, we're not talking about doing super deep analysis. It's mostly around generating some data or metric collection about the log files, and then taking those metrics and sending them to another place. You essentially still need a central point to go to, whether it's a hosted one or it's local inside your infrastructure, so that's not going to change. And you still need some sort of agent process, whatever it might be, to look at your log data and generate those metrics. So we're going to talk about a couple of those options here now. The first one is an Amazon service. So this is CloudWatch Logs, which we launched this past summer. CloudWatch Logs is a component of CloudWatch, which has been around for a very, very long time. And essentially, you can use either an agent, the CLI, or the SDK to take logs from your hosts and applications, send them up to CloudWatch, and then be able to interact with them after that. You centralize those logs, and you can go and view the raw logs yourself. But more importantly, the power of CloudWatch Logs is that you can generate metrics on the fly based on your log data, send those metrics to CloudWatch, and then you get all the nice capabilities of CloudWatch in terms of generating alerts based on those metrics that can go to a number of places, being able to pull that metric out via the APIs or SDKs into other infrastructure components, monitoring, whatever may have you. Really, really straightforward and easy to get going with CloudWatch Logs. This is an example on a Linux system, in this case an Amazon Linux system. I install the AWS Logs package. After that, I need to create a configuration file, and essentially these bottom 7 lines here are the ones that I care about in terms of wanting to follow the access log that's created by Apache. You can see there's a couple of configuration parameters that I have to fill in. And then over here on the far left, your right in this case, is the command that I'm going to use to put a metric filter into CloudWatch. And so what I'm doing here is I am defining a filter name, a filter pattern, and then saying which part of that pattern I want to send up as a metric. In this case, what I'm looking for is the metric request time. So that is the request time that I added into my Apache log file before when I added in the %D. So again, we want to worry about the data that's important to us and act on that, analyze that, graph that, whatever it might be. This is the result that you would see in the console if you went to look at this log data once it's been centralized. What I've done here is kind of highlighted that value over there on the far right of what I care about in terms of what I'm looking to analyze. Down at the bottom here, you can see the metric that's generated by this. I was doing this on my own test server. It wasn't serving anything really interesting or exciting, so there's actually not too much variation here in request time if you look at the actual values. But again, super powerful, right? I could very easily now add some sort of an alarm on top of this if I want to say, don't allow the site to get above a certain point. I could use this metric to do things such as trigger auto-scaling. Lots of capabilities once this data exists inside of CloudWatch for me. And again, very, very easy to set up. In Windows, it's actually even easier. On a Windows AMI, once fired up, you go and load the EC2 Service Properties tool. Click over on this checkbox here for enabling CloudWatch Logs. Then there is this wonderful JSON file that you can edit to say which logs you want to tail on the system. And then, again, in CloudWatch, you can set that metric and get the graphs that we saw in the previous slide. So that's CloudWatch Logs. The next one up is something that's near and dear to me. I used to work at Etsy previous to working at Amazon. Pretty popular website based in New York City. And they released an open source tool called Logster a number of years back. And essentially, Logster allows you to generate metrics from log files. And kind of like the CloudWatch Logs agent, allows you to take those metrics and send them someplace. So that could be someplace like Gangly or Graphite, or actually even CloudWatch. So you could use this on-prem in your own data center and send this data up to CloudWatch very, very easily. Typically, though, it runs via a cron as opposed to running as a daemonized agent like the CloudWatch Logs agent does. So you have to set up a cron entry, pretty straightforward. And then it also depends on the logtail package, which you'll find on almost any Linux distribution today. So what it's going to do is it's going to periodically, again via that cron job, tail my log file. It keeps a marker on where it left off from the previous iteration, and then allows me to generate statistics about my log data. In this case, and then again send that generated metric off to whatever destination it is that I'm looking to send it to. In this case, I'm doing an example of sending the output to Ganglia, which is a graphing tool that's very popular in the monitoring metrics world. And what you can see down below is the example of the gmetric command, which is what you use to send data to Ganglia. And it's kind of difficult to tell here, but in the very bottom right-hand corner is that 0.533333 kind of repeating metric that is the requests per second that I'm getting to this server. Again, this is not a high-traffic server, so half a request per second, not very much interesting going on here. But again, really, really straightforward to use, very easy to install, very easy to generate these metrics from your log files. Going back to Logstash here, again, Logstash is a really, really powerful tool. It's very multifaceted. You can actually also generate metric data from Logstash running on your actual end instance. You can do this both here on your every server in your infrastructure. You could also do it on those centralized collection nodes that are passing that data back into Elasticsearch. And so, again, it can process logs on the fly based on tailing log files that are being created on your host. And it has, again, such a huge, huge, huge collection of outputs that it can send it to. Here we're seeing just a brief example. So again, CloudWatch, Ganglia, Graphite via the StatsD plugin, third-party tools like Boundary and Datadog, many, many others that exist out there that you can send this metric data to, that Logstash has plugins, again, from many of these different third-party companies. Logstash runs as a constantly running process, so it's not the kind of thing that has to wake up as part of a cron job. And then, again, a little bit easier than Logster. You can see over here on the far right an example of a configuration that I would need in order to generate this data. Basically filter it, essentially match it against a pattern, and then take a value that I care about from that pattern and send it off to StatsD. So very, very straightforward kind of configuration to do this. And again, this configuration here could live as part of your larger configuration for centralizing your logs at the same time. So Logstash could both generate metrics and centralize logs all at the same time, part of the same process. Very, very straightforward. So we've seen kind of the two options here for getting this data off of our host. Again, we can either centralize the raw log data, analyze it later. We could, or do the other option, which is get metrics that we care about from our log data, centralize that to another location. So once we've done that, the next thing that we'd want to do is analyze that data, which usually happens in the form of dashboards. For those who don't know the historical context behind the word dashboard, essentially you can see it highlighted here in this carriage. Dashboard was used to protect you from having mud flinged on you by horses when they were to dash. Learned this recently from the History Channel. Good stuff. So essentially that was the original context of it. As cars came about, it became the place where gauges sat on. And nowadays, all of us in the IT world have taken this to mean a place where we look at pretty lines and graphs and things like that. So some tips on dashboarding. This is another topic very near and dear to me that I could spend a whole lot of time on. You want to make all the metrics available that you possibly can for inside of your organization. Enable as much cross-team metric collection as possible. You'd be surprised at what one team looking at a graph might pull out of it from another team, all based on the same graph sometimes. Focus your main landing or dashboards that you have up on TVs in your office on metrics that are really important to the business or your end users first. That's something that I don't see a lot of people doing these days. I see things like RAM utilization on a big TV in someone's office, and I say, how many of you stop and look at RAM utilization in a day and draw something useful out of a metric like that, right? Nowhere near as important as things like checkouts, logins, login failures, other sorts of useful user actions that you might have. Another one is, and lastly, again, find a way to highlight organizational events and changes inside of your infrastructure. So if you have deployments, configuration changes, potential outages, anything that might happen, find a way to put that up on that dashboard. You'll see very commonly people draw a vertical line and correlate that vertical line in the graph with some sort of action, and many different graphing and monitoring tools allow you to do that. So again, talking about metrics that matter, we have two examples here from CloudWatch. The top one is CPU utilization from an individual host. The bottom one is latency from an elastic load balancer. Ask yourself which one of these is going to be more important to you. If you said the elastic load balancer latency, that's correct. All right, this is something that's correlating directly to what your users are experiencing. You could run web servers at 100% CPU 24/7, and if the latency of your page request time is low enough, who cares? But if your page latency is very high and your CPU load is very low, right? Again, you want to be paying attention to those metrics that are actually impacting the business and impacting your users. So a number of different dashboards out there. Again, going back to Splunk, really awesome product that we heard a little bit more about today. Splunk has a very, very powerful web interface that has a very, very complex and powerful query and filter syntax for looking at log data and correlating it, doing all sorts of good stuff. Has a number of really cool visualization plugins. One of my favorite ones is that it puts up a map and it can show you where requests are coming from on that map in near real time. That's pretty fun. And then a number of third-party apps that you can drop and plug into that interface to do all sorts of other visualizations and understanding of your data. We have an app for Splunk that pulls in things like CloudTrail data, so that's extremely useful. And then the other great thing about it is that it actually exposes an API. So many companies have written their own dashboards using their own dashboard tools, using the data from Splunk and then portraying that into that dashboard. This can be really useful if you have many different places that you're collecting data from. You're not going to have to go back and look at one dashboard, look at the other dashboard, look at the other one. You can kind of suck all of this stuff in together. So that's pretty nice. And again, it scales really, really well. So just a quick screenshot of the Splunk Web Interface. Pretty straightforward here. And sorry if it's a little difficult to see in the back, I'm saying which file I want to have my source, and then I'm looking for 400 messages in it. Now I'm not specifying where in the log file there's going to be a 400. I could have actually filtered this down based on a certain field, but in this case, a very generic search of show me anything in this log file that matches a 400. So again, my not very exciting personal website doesn't generate a whole lot of log information, nor does it generate a whole lot of 400s, but you can see a couple that happened here. Next up is Kibana. This is the K in the elk stack, with the E being Elasticsearch, which we're not going to talk too much about here today. Kibana was an open source project that the main developer on it actually joined Elasticsearch sometime in the last 12 months, maybe a little bit longer. Same thing actually goes for the original developer of Logstash. So it's actually pretty cool. You had 3 open source projects, one that became a commercial entity, which was Elasticsearch, which then brought in the other 2 people that had kind of put together this trifecta of application stack, which is now called the elk stack. So Kibana, really, really powerful open source dashboarding tool for Logstash and Elasticsearch. Again, it integrates with Elasticsearch as the backend that it's going to pull data from. Lots of great search filters and features, also great visualizations, very customizable, right? It's an open source tool. You can go in there, play with the code, make it work exactly the way that you want to, or customize the way that you want to. And the other thing is that it can also read data from other centralizing tools such as Flume or FluentD. So Kibana, here's an example of a dashboard again. What I have here is a histogram showing the requests over a period of time. Then down below you can see a couple of other dashboard components. I have the HTTP method used. Again, unfortunately for me, not too exciting of data. The user agents, and then the response code that my very exciting personal web page is generating. But what was really great is that, again, you can drag and drop this, play with this, customize it, the kind of thing you could throw up on a TV in your office or somewhere and be able to see, again, a whole lot of data in one place. Both of these examples in this case, both Splunk and Kibana with the elk stack, I took the time to set them up here. Both of the examples individually took less than an hour. Right? This is really straightforward to go through their how-to and setup guides, follow through, and be able to do this. So again, neither of these are so complex that it should take weeks of time. This is the kind of thing that you could spend part of an afternoon getting started with, and of course, obviously, iterate over time with it. So we've gone through the first 3 steps of our 4-ish steps to web operational log analysis greatness. Generate useful log information, right? Let's make sure that our logs have some sort of value to us. Get that data off of our web instance, right? Get it to the centralized place that we're going to hopefully redundantly store that log data. Analyze that data. Right? In this case, we're talking about manual analyzing tools here. And then now the 4th step is to actually do something further acting on that data, right? So alarm and act on that data, or trend it, or do something useful here. And actually, this is the part of the talk that while working on these slides, felt that I couldn't go anywhere near into as much depth as I wanted to. When you talk about things like dashboards, they're a very manual human aspect to looking at those. And surprisingly enough, us humans and our eyes and our brains are really, really poor at doing log analysis. You really want to have something that is automated, that is looking through these things, that is grepping, looking for patterns, looking for outline data that doesn't make sense. And so that's the kind of thing that you really want to rely on other tools for. Splunk and a number of other tools allow you to do things such as find confidence bands, predictive analysis. There's a number of third-party open source tools that exist out there today that can do these things as well. Right? Being able to say, okay, there's a spike in this graph. Is it something that I care about or something that I don't? In a large environment where you might have hundreds of data points to look at, it's difficult to say, well, if I'm looking at a 24-hour window, how does that correlate to a 7-day window, a 30-day window, and being able to say, okay, this is something that's a problem. This is something that I should alarm on. So essentially, again, it's very difficult. I feel that alarms are a bit of an art first and then a science kind of second. And essentially, the whole purpose of collecting this data in an operational sense is to have a deeper understanding of what's going on in our infrastructure, being able to react to it. So when it comes to reacting to information in your logs, again, you want to follow the same kind of patterns that you would for looking at dashboards. What aspect of these logs is important to my end users primarily, and then to me as an operational organization secondly? So first, basic things. Is the site up? Are my servers up? Are things responding the way that they should be? Is the site slow? Are page response times higher than they were previously? And again, determining what slow means for you is obviously very much an individual type of a thing. Are certain user actions failing more than others, right? Are people getting through the site, searching, picking a product, but then checkout is failing? Right? That's the kind of thing you would want to know about very, very quickly, and log data is kind of one of the best places to know about that. And then again, is something like checkout much slower than it should be? Does it normally take 200 milliseconds, and right now it's taking 4 seconds, right? What could be causing that? Again, log data, one of the best places that you could get that information about. So after you focus on what's important to your customers, then it makes sense to do alarming and alerting on data that is more kind of infrastructure operational. So things like filling disks on databases, other technical capacity limits that something like auto-scaling can't get away from. Our internal services down or slow. For instance, paying attention to log data that tells you, again, that the site is down or things are taking a very long time to run matters a lot more than potentially, say, alerting on something from some sort of internal daemons process that doesn't affect your end users. When it comes to actually doing something, again, in terms of reacting on the log data that you have, it's going to be very much dependent on what tool you're using to collect and analyze that log data. CloudWatch has built in a whole bunch of ways that it can reach out to you via SNS, Simple Notification Service. So that could be that could be HTTPS, email, Amazon, I don't know what it says that. It should be SMSs or Amazon SQS. Logstash has integration with things like Nagios, also SNS, email, a bunch of third-party tools. Same thing with Splunk, lots of plugins for email, Nagios, third-party tools. And then lastly, if you go with a SaaS option, you see a lot of integration today also with these things. Down at the bottom, 3 really awesome tools for handling things such as getting messages out to your team. If you have an operational team and you rotate the pager and who has it, PagerDuty, OpsGenie, and VictorOps can all help you do that kind of operational rotation and escalations and responding to incidents and stuff like that. So we've gone through our 4-ish steps, again, all of which are represented by many sub-steps. But there's actually kind of a 5th point that comes after the fact of all of the kind of useful operational things that we would do with our log data. The first part of that is log backup and archiving. And this is what I always like to say to a company when we talk about this is, you aren't just going to delete the logs after a couple days, right? If you have a 2-week window that you've been storing data for, you're not just going to toss that away on that 15th day. And there's lots of reasons why you wouldn't want to do that. For many companies today, across many sectors, there's regulatory needs to keep log data of varying different aspects about your end users. Sometimes it can be very useful to keep logs for long-term trending and analysis. Potential product uses. So I've seen recommendations generated by logs. I've seen features that we go and look at, things like A/B testing based on log data. And then lastly, things like security reviews. Right? Do you have the ability to go back and look at people that might have been doing attacks against your web server a month ago versus today? How has that changed, and so forth. Log backup and archive. I actually think this is a very easy thing to do properly. Again, many of the tools that we talked about today have the ability for you to dump your data up into S3. Logstash can dump into S3. SaaS options like Loggly and Papertrail allow you to toss things up into S3. And then Splunk, which I don't believe has the capability to do this though, if you're storing your data on EBS, you could always make snapshots, keep those snapshots for some period of time. So once you get the data into S3, for long-term storage, again, if regulatory needs tell you need to keep log data for potentially up to 10 years, you're going to want to get that data into something like Glacier. And so that might sound hard, but it's actually really, really easy. So if we take the example of using CloudFormation to do this, CloudFormation, another AWS service that I really love and try to use as often as possible, what we can see here is an example of a couple of lines in CloudFormation, how to split it across 2 windows here. But essentially, I'm defining an S3 bucket. That S3 bucket has a lifecycle configuration where I'm specifying that data that is in this bucket, prefixed by the word logs, after 30 days will get rotated to Glacier, and then will be kept there for 365 days. And I had to do nothing more to enable that or to work with that than to have this set in the definition of this resource in CloudFormation. Another thing that's really important in terms of logs that we didn't cover today is security of logs. Again, because this represents such important information to your website or to your application, securing it is a really, really important thing to do. So obviously restrict access to the raw log data, to where it's being stored, to where it's being backed up, security groups, network ACLs, local access restrictions on your hosts, right? You wouldn't want someone modifying your security logs to clear their tracks of what they're doing that might be nefarious on your systems. Protect and track any sort of changes to those logs, right? Things like MD5 sums, controlling an IAM who has access to these S3 buckets, EBS snapshots, or whatever it might be. And then another really great trick with log data, because of its importance, is actually ship it to an S3 bucket that is owned by a different account than your primary account, which you can do these days with cross-account sharing of S3 data, and then enable MFA delete and versioning on that data. What this does essentially is make it very difficult for anyone to get access to this bucket and potentially delete the data, again, without an MFA token, and then take that MFA token that you've used and put it in a bank safe or something like that, right? Make it so that it's very, very difficult for anyone to ever get access to your account and then potentially delete this very important data. And then lastly, really, automation of logs, right? You don't want to be going in and configuring logstash in every host by hand. That's just not going to scale well. Use configuration management tools, Chef, Puppet, Ansible, Salt, whatever you might have. CloudFormation, obviously, with metadata and user data, you can also set this up when your instances start. And what I always like to do is have some basic level of log centralization or metric collection built into every AMI that I have. All right, if I have some sort of higher level process like a Chef or a Puppet that's going to be taking my log or configuring some aspect of my host later on, but that has the potential to fail, then I want to make sure that my host, as soon as it starts, is still capable of sending me the logs that would be generated by those processes. So again, have that base AMI, have something that's in place already to send those logs. So we've covered quite a bit here today, my 4-ish steps that you could follow to doing log operational analysis in the case of web logs or other logs. Again, with that kind of asterisk 5th bullet point down here of backup and archive, security and automation. Again, pay attention to the data that you're generating via your applications and web servers. Make sure that it's pertinent and important to you, right? Cut out the crud that doesn't matter, add in the aspects that do. Get that data off of your web instance as quickly as possible, right? Get it someplace where you're going to be able to later analyze it in an effective way without potential for loss. Then analyze that data, right? Figure out what metrics matter to you. Take those metrics, put them into some sort of a dashboard or some sort of a tool where you could track them, trend them, and then eventually potentially alert or alarm on them and have better understanding. So in closing, again, logs are super, super important. I find that logs are fun. Look at this guy here. He's having a ball right now dealing with logs. And again, spend the time to do log analysis right. It's super, super valuable to an organization these days, a critical part of how your infrastructure is working, behaving, how your users are interfacing with your services. And if you're doing nothing with this data, you're really losing a whole lot of value. Again, here are kind of the 5 points. A little over my time here. Again, unfortunately, I'm not going to be able to take questions right after this session. You can email me, my last name, munz@amazon.com, and I'm happy to have further conversations with you. I really do appreciate any feedback that you can offer up on this session to help me understand what you liked, what you didn't like, what you'd like to hear more about. And with that, thank you again for joining us here at reInvent this year, and have a good rest of your week.